Hi, welcome to this lesson on Euclidean geometry, the proportionality theorem. Let's have a look at question 5. So in triangle ABC, x is a point on BC, so that's this point here. N is the midpoint of the line AX, and Y is the midpoint of the line AB. We're also given that M is the midpoint of line BX. Okay, we want to prove that YBMN, so this shape here, we want to prove that that is a parallelogram. So what do we actually need to prove? So we need to show the following criteria is true. So to show it's a parallelogram, we need to show that the opposite pairs of sides are equal. So first we want to show that BY equals MN, and we want to show that YN equals BM. That's what we want to show. And then we also need to show that the opposite pairs of sides are parallel. So we want to show that BY is parallel to MN, and we want to show that YN is parallel to BM. So if we can show all four of those properties, then we can show that YBMN is a parallelogram. So let's have a look at the proof. Okay. So first I'm going to note a few things. There's quite a lot of information, a little bit of an information overload on the diagram. So we need to try and piece all this information in a constructive way that'll help us. Okay, so first of all, I can see that because y is the midpoint of this line AB, therefore AY equals BY. Okay, because y is the midpoint. So that's useful information, so I'm going to write that up there. We're also told that M is the midpoint of BX, so that means that BM equals MX. And then lastly, we're told that N is the midpoint of AX, so that means AN equals NX. So that's useful information to know because we might need to use it. Okay, so now we have triangles with some parallel lines and midpoints, so that kind of brings to memory, well, proportionality theorem and also the potential use of the midpoint theorem. Okay, so first of all, if I want to show opposite pairs of sides are parallel, I can maybe try use the converse of either the proportionality theorem or the midpoint theorem. So if I look here at BY and MN, okay, I notice a triangle that forms out here, and I'm going to construct it as follows. So this is going to be the triangle ABX. Okay, so what is in ABX? Well, first of all, there's a midpoint N here and a midpoint M here. So this creates a midpoint here and a midpoint here, and there's a line that's constructed. So when we have a point that is a midpoint on one side of a triangle that connects to the midpoint of another side of the triangle, okay, then by the converse of either the proportionality theorem or midpoint theorem, that implies that these two lines must be parallel. So I'm going to note that down. So I'm going to say in triangle ABX, we have that the proportion, so BM over MX, so this distance over that distance, because they are equal to each other, hence midpoints, that's just equal to 1, okay, because they are equal to each other. That is also in the same proportion as AN over NX. And again, those are also equal to each other because of midpoints. So because that proportion is true, okay, therefore that implies that the line MN is parallel to the line AB. Okay, and that is by the converse of proportionality theorem. Okay, or you can also say the midpoint theorem because it connects between two midpoints. All right. Because the midpoint is just a special case of the proportionality theorem. It just shows that the proportions are actually equal to one specific value. Okay, so we've shown that MN is parallel to AB. MN, this line here, is parallel to AB. But AB, okay, so BY is on the line AB. So this also implies then that MN is parallel to BY. And that's exactly this first part that we've proven here. Great, so we've got that done. Okay, so that's parallel. Okay, and then we can use a similar argument, right, that we can show that BM and YN are parallel to each other. So what I'm going to do is I'm going to look at the same triangle now. Okay, so ABX, right? But now this time there's a midpoint Y and a midpoint N that is constructed here. So these two are in the same proportion. These two are in the same proportion. So I can say in triangle ABX again, we have that AY over YB is equal to 1 is in the same proportion as AN over NX. Okay, so these proportions here, AY to YB is the same as AN to NX. Okay, so then this implies that the line YN is parallel to the line BX. Okay, but BX, the line BM is on the line BX. So this implies that YN is parallel to BM. And we've proven that second part. So we've shown that these two lines are now in fact parallel to each other. All right. Okay, so we've shown the two parallel lines are parallel. So essentially now what we want to do is prove that the length BY is equal to the length MN and that the length YN is equal to the length of BM. Okay, so now this is where I'm going to use the proportionality theorem as follows. Okay, so let's look at the first one here, BY. So in this triangle here, this second one here, here's BY, and MN is over here, this proportion here. All right, so how do we show that these two are equal? Okay, so we just need to find the right triangle to look in and then use the proportionality of them. Okay, so first of all, I'm going to notice something. By the midpoint theorem, this distance AB, okay, is twice the amount of MN. That is by the midpoint theorem, because these two are midpoints here. Okay, so I'm going to say by the midpoint theorem, we have the following. So AB must be twice the amount of MN, okay? Right, but AB, can you see, this here is just two amounts of BY. Okay, because these are equal, because Y is the midpoint. So you have 2BY equals 2MN. If I divide both sides by 2, I get BY equals MN. And we are done. Okay, so there we use the midpoint theorem. Very helpful. And then let's use the midpoint theorem again to show that YN is equal to BM. So again, because these are midpoints here in triangle ABX, I can say that the length of BX is twice the length of YN. But BX itself is 2 times the amount of BM. Okay, because again, M is a midpoint between these. Okay, so I have 2BM equals 2YN. So therefore, dividing both sides by 2, I get BM equals YN. So we've successfully proven that this shape here, YBMN, is a parallelogram. So the main goal was looking at this triangle ABX and then extracting the relevant information from it, both using the proportionality theorem and the midpoint theorem. All right, so that's how we would do this type of question. I'll see you in the next one.